Welcome to qnawire.
Here we're going to have an aquarium which is going to be held at pH equal to H. We want to know in what forms of ammonia of NH3 versus NH4 plus are going to be present in solution. So in this case, the ammonium ion in aqueous solution can undergo the following reaction in water to produce NH3 aqueous plus H3O plus in aqueous solution. So if we're given a certain value for an initial concentration of NH4 plus, what we're going to have is that at equilibrium we're going to have a change equal to minus x plus x and plus x, and we're going to get C0 minus x, and at equilibrium. So in this case, if the pH is equal to 8, that means that the concentration of H2O plus that we're going to have in solution would be equal to 1 times 10 to the minus 8. Furthermore, we know that the value for pKa is equal to 9.24, so in the case that we were not given the value for x and we were given only the initial concentration of the NH4 plus ion, we would be able to know how much we would have left. In this case, since the pH is equal to 8 and the pH is lower than the value for the pKa for the acid, that means that the acidic form will be prevalent in solution. And according to the equilibrium, while keeping a pH equal to 8, we should have exactly 1 times 10 to the minus 8 of NH3. So we can calculate the value for C0 given the Ka. The Ka is equal to 10 to the minus pKa, and this would be equal to the concentration of NH3 times the concentration of H2O plus divided by the concentration of NH4 plus. This is going to be equal, replacing the values at equilibrium, to x squared divided by C0 minus x. But in this case, contrary to most of the scenarios, we know the value for x and we don't know the value for C0. So again, in this case, this would be equal to 10 to the minus 9.24. So solving for C0, we're going to get that C0 times 10 to the minus 9.24 minus x times 10 to the minus 9.24 is equal to x squared. So C0 is going to be equal to x squared plus x to the 10 to the minus 9.24 over 10 to the minus 9.24. We know that the value for x is equal to 10 to the minus 8 according to the pH of the solution. So this is going to be equal to 10 to the minus 8 squared plus 10 to the minus 8 times 10 to the minus 9.24 divided by 10 to the minus 9.24. So this is going to give us a C0 equal to 1.8378 times 10 to the minus 7, which is already larger than 1 order of magnitude more than the concentration of NH3, and the fraction that dissociates would be equal to 1 times 10 to the minus 8. So this is going to give us a percent of this dissociation, or percent of ionization, equal to 1 times 10 to the minus 8 over 1.8378 times 10 to the minus 7 times 100 equal to 5.44%. So in this case, what we're going to have is that the most of the species is going to be on the NH4 plus form, and 5.44% would be on the NH3 form. So 94.56% would be in the NH4 plus form. With that, it would be all. Thank you very much, and have a good one.